We are now dealing with simultaneous linear equations, and in this case we are dealing with very special cases. So case 1 is this. We have that this part of the equation is equal to this part and is equal to this part. So we have three equalities. So no worries. Since this part is equal to this part and equal to this part, what we are going to be doing is that we are going to be equating this first part to this and this second part to this. And then we collect like terms. So we have that 2x minus 3y plus 2 is equal to 3x plus y. And on the other hand, we have x plus 2y minus 5, that is the second part, is equal to 3x plus y. So it's easier to equate to the simplest part of those three equalities. In this case, just this one that has two terms, but anyone, it's okay. Anything you do is okay. So we collect like terms. We have that 2x and then minus 3x, that's crossing over. We have minus 3y from here, and plus y comes over to become minus y is equal to plus 2 goes over here to become negative 2. So it's important for us to make the constants to stay on this other side of the equation. We now have 2x minus 3x is equal to negative x, and then minus 3 minus 1 is equal to minus 4y and is equal to minus 2. So this is down a simple equation. I can even call this equation 1 right now. Then for this, we have x is already here, minus 3x comes over, plus 2y, and then minus y crosses over is equal to minus 5 crosses over to become 5 here. So x minus 3x is minus 2x. 2y minus 1y is 1y is equal to 5. So this is equation 2. So these are the two equations we shall be working with. So it's our choice to decide whether to equate the coefficients of x or to equate the coefficients of y. But let me go for equating the coefficients of x. So what I'm going to do is I'm going to multiply equation 1 by 2. So we have 2x here just like we have 2x here. So equation 1 multiplied by 2 gives, let me have that here to create space for minus 2x minus 8y, that is multiplying this. 2 times minus 2 is minus 4. So I'm going to repeat equation 2 so that we can add or subtract according to the signs of the unknowns. Okay, minus 2x, that's equation 2, plus y is equal to 5. So seeing that they have same sign, we are going to subtract. So that's minus 2 minus 2x. So that minus coming together becomes plus. So this becomes minus 2 plus 2x, giving us 0. So that means we have eliminated the coefficient of x. So when we subtract, we are going to get that minus 2 minus minus 2, that's minus 2 plus 2 is equal to 0. Minus 8 minus y is equal to minus 9y. And then minus 4 minus 5 is equal to minus 9. So we divide both sides by minus 9. And we have that y is equal to 1. Now on this side, I'm going to solve for x. And then when I solve for x, we are going to substitute into, maybe let me use equation 1. Equation 1 that we have, or let me use equation 2 that we already have here. So we have minus 2x plus, instead of y, we have 1. 1. And then is equal to 5. According to this, we have minus 2x is equal to 5 is already here. Plus 1 goes over to become minus 1. And then we have minus 2x is equal to 5 minus 1, 4. And we divide both sides by negative 2. And we have that x is equal to negative 2. So the solutions to the simultaneous equation is that x is equal to negative 2 and y is equal to 1. And when you substitute into the given equation, you're going to see that it satisfies every condition. Now, this is another special case in which the unknowns are at the powers of the given equation. So don't panic. Seeing this, what we have to do is we are going to get these two equations as a base. So this will be in base 2, this will be in base 3. So that what we are going to have is that this is already in base 2, x plus 2y is equal to, instead of 1, anything raised to power 0 is equal to 1. So we are going to get that one in base 2. So 2 raised to power 0, 1, so representing this side. And for this, we have 3 raised to power 2x plus y is equal to, instead of 27, we are getting 27 in base 3, which is 3 raised to power 3. So what we are going to now do is we are going to equate powers. Equating powers, we have that x plus 2y is equal to 0, and we have that 2x plus y is equal to 3. So we've eliminated the bases. So we can call this equation 1 and this equation 2. Now you can see that they look like normal equations that we can work with. Now working with these equations now, we can multiply this equation by 2 so as to get the coefficients of x equal, or we can multiply the second equation by 2 to get the coefficients of y equal and therefore eliminate them. Let me go with multiplying equation 1 by 2. I have equation 1 multiplied by 2 to give me 2x plus 4y is equal to 0. And then I repeat equation 2. Equation 2 remains 2x plus y is equal to 3. Now, considering this, so 2 minus 2 is equal to 0. So I'm going to say subtract. We have that 2x minus 2x is 0. No need to write that. 4 minus 1 is equal to 3. And then 0 minus 3 is negative 3. We divide both sides by 3. When we divide both sides by 3, we have that y is equal to negative 1. And then on this other side, I'm going to solve for x. For x, I have to substitute maybe into equation 2. We have 2x plus, instead of having y, we have negative 1 is equal to 3. And then 2x plus times minus, that's negative 1. 3 is already here. Minus 1 crosses over to become a plus 1. We have that 2x is equal to 4. Dividing both sides by 2, I have that x is equal to 2. So the solution to the simultaneous equation is that x is equal to 2 and y is equal to negative 1. Now, considering that this was a very strange question, let us satisfy our curiosity by substituting into any of the given equations to confirm that x equal to minus 1 and y is equal to x equal to 2 and y equal to minus 1 satisfies the two equations. Okay, I'm going to have one of the equations repeated. So substituting into this very first one, this one, I have that 2, instead of having x, that is x is 2 plus 2 into minus 1. Let's see. So we have 2 raised to the power 2. 2 times minus 1 is minus 2. And then minus 2 plus, that is plus minus is minus 2 minus 2 is equal to 2 raised to the power 0. And we know that anything raised to the power 0 is 1. So we can see we've confirmed it that this is satisfies this, and you can try this other part on your own. Now look at this equation we've been told to solve simultaneously. What we're going to do is we're going to eliminate fractions. So for the first equation, we're going to multiply all through by 3. So that we have, when 3 multiplies this part, 3 cancels out this 3, we have x minus 3y is equal to, on this other part, 3 multiplies to give 6. So this forms equation 1. On this other part, we are going to cross multiply so as to eliminate the fraction. When we cross multiply, 2 multiplies this and then 4 multiplies this. So when we do that, we are going to get that 2x, that's 2 times x, plus 2y, 2 times y, is equal to 4 times 1, which is 4. So this forms equation 2. Now, these are equations we are going to work with. I'm going to multiply equation 1 by 2 so as to equate the coefficients of x. Equation 1 multiplied by 2 gives 2x minus 6y is equal to 12. And then I'm going to now repeat equation 2 so that we can perform an operation on them. Plus 2y is equal to 4. And then we can subtract now. Subtract. So that's 2x minus 2x is 0. And then minus 6 minus 2 is minus 8y equal to 12 minus 4 is 8. Therefore, we divide both sides by negative 8. We have that y is equal to negative 1. Now, we can solve for x on this other side. We have to substitute into any of the equations. Let me pick equation 1. We have that x minus 3 into negative 1, which is y, equal to 6. We have that x is equal to minus 3 times minus 1 is plus 3, equal to 6. We collect like terms. X is equal to 6 is already here. Plus 3 crosses over to become minus 3. Therefore, x is equal to 6 minus 3, which is 3. So what satisfies the given equations is that x is equal to 3 and y is equal to negative 1. You can substitute that and confirm. Now see these decimal fraction equations given to us. So whichever equation you see, never you panic. Any special cases you see, never panic. So what we are going to do is that we are going to be eliminating the decimal fractions. And thank God this is just in one decimal place. So when we multiply all through by 10, both equation 1 and equation 2, we are going to get equations that does not carry decimal fractions anymore. So multiplying all through by 10, we have 23x plus 18y is equal to 51. And this makes equation 1. And we have 9x plus 24y is equal to 3. This makes equation 2. So on my rough work side, what I'm going to do is that, considering these two numbers, this number is a prime. So I can't be multiplying this by 23. So considering these two numbers, they have something in common, which is 6. They have 6 in common. So I'm going to say something like this. This is what I'm going to do. The ratio between 18 and 24. So when I divide by 6, I'm having 3 and I'm having 4. So meaning that I'm going to interchange. The equation that carries 18 is going to multiply by 4 so as to give the same number, the same value, and then the equation carrying 24 is going to multiply by 3 so as to give the same value. So what we are going to do is that equation 1 will be multiplied by 4 and equation 2 will be multiplied by 3. When we do that, we are going to have that 92x, that is 23 times 4 is 92, plus 18 times 4 is 72, 72y, 51 times 4 is 204. And then for this part, 9 times 3 is 27x, plus 24 times 3 is 72y, 3 times 3 is 9. Very good. So we can see we've equated the y, the coefficients of y. We are now going to subtract so that plus 72 minus 72 is 0. Subtract. Have 92 minus 27 is equal to 65. 65x, this is 0, equal to 204 minus 9 is 195. We divide both sides by 65. And then we have that x is equal to 3. Wow, this gave a very simple answer. So we're going to solve for y. And let me substitute into equation 2. That looks simpler. We have 9 into x, which is 3, plus 24 into y is equal to 3. We have that 27 plus 24y is equal to 3. We collect like terms. We have 24y equal to 3 minus 27. We have that 24y is equal to 3 minus 27 is minus 24. Therefore, we have that y is equal to, we divide both sides by 24 to get minus 1. So the solutions to the given equation is x equal to 3 and y equal to minus 1. Now you can go ahead, substitute, and confirm that it satisfies the given equation.